Okay, so welcome to MAD. Today we are going to be talking about the shell, and this is going to be both a very brief introduction or a quick refresher, and it's not supposed to be comprehensive, and at the end of this lesson we don't expect anybody to be expert at these things that we're teaching, but it will act as sort of a first introduction or a first thing to see, and it'll connect you to other resources and other things that you can use to continue on your journey toward learning the shell. So this lesson is just a quick introduction, but we've provided a lot of links at the end if you would like to learn more. And if you go to this URL here, you'll have access to this lesson material. And then we'll also be doing some live coding too, if you would like this. So that URL is tinyurl.com/2019-mad-shell. Okay, so the things that we're actually going to be covering today are our objectives. We want to describe what the key reasons are for learning the shell in the first place, talk about navigating a file system using the command line, practice copying and moving files using the command line, understand basics of what remote computing is and why we use remote computers or cloud computers, and then we'll practice or do a little bit of show and tell with downloading some files from the internet and talk about the secure commands SSH and SCP. So again, the goal of this is not for you to have a comprehensive understanding of all of these things, but be exposed to them and see how they act so that you can continue building your mental model using different resources as you start using these tools. So the first thing that we want to talk about is how to access the shell. So if you're on a Mac computer, you can go to this spotlight icon up in the top right-hand corner of your screen. It's the little magnifying glass. And if you type terminal, a terminal will open up. My default terminal has really bad colors, so I'm going to change it to a different one. And then I'm going to do a split screen view here. Okay, maybe a little bigger. So, and if you're on a Windows computer, it's a little different. If you're running greater than Windows 10, then you can use the Ubuntu subshell. And if not, then you can install a program called Git Bash. And then Linux also has a terminal program. So those are sort of the ways to access it. Okay, so before we get started on sort of clicking away over on our shell, typing away, we want to talk about why we would even bother using this to begin with, right? Our computers already come with these beautiful interfaces that you can click and point and use. And these are a lot more, that thing where I forget my words is going to be real difficult. Opaque. The shell is a lot more opaque than a graphical user interface might be. But we do have significant motivation to start using the shell. So many bioinformatics tools need the command line interface or the shell, and they don't have a graphical user interface. Or if they do, you'd have to point and click thousands of times to enable yourself to use them, versus you can automate all of that with the shell. So that makes your work a lot less time consuming and a lot more consistent, and helps you make less mistakes. So those are sort of like the key benefits to why we would be using this to begin with. It also helps your future self to do the exact same thing that you've done before. So it makes it more reproducible and more repeatable, which is really important if you get a new data set, or if you are unsure about results, or you're getting something weird, you want to go back and redo everything. The shell will make that infinitely easier than having to point and click over again. And then the last thing is that many of the bioinformatics things that we'll be doing require a lot of compute. So a lot of hard drive space or a lot of memory. And so you can't do it on your machine, and it's required that you use an external machine. But the only way to talk to those external machines is to use the command line or the shell. I'm using those terms interchangeably. But so those are sort of our motivations. I'm assuming if you're here, then you're motivated to learn this because of those things. Can you think of other motivations that you might have, or do these jive well with the things that you've been exposed to? Alicia's giving me some thumbs up. What about, do you have other use cases, or are you aware that this is the need and now you want to know how? Yeah, okay. Just be cool like all the cool kids. Yes, me too. Okay, so let's talk a little bit about using the command line to navigate around our computers and through different files and directories. So let's dive right in. So if we learn our first command, or the first thing that we're telling a computer to do, PWD is the one that we're going to be using here, and it stands for present working directory. And I see that mine is /users/tr. So that tells me where I am on my computer. But what does that mean? Computers have hierarchical structures of where they keep their different folders and files, and they're organized in a very specific way. And this is sort of where you usually start out, and it's called your home directory. And that can be sort of an amorphous concept if you've never seen a home directory before. But if I show you the contents of a home directory, that's my home directory. So this is what it looks like. Everything that's inside of my home directory. So these are the things that you're sort of familiar with when you log into a computer. You have things like your applications or your pictures or your desktop, things that come on the computer, and that this is sort of, when you log in, how you orient your frame of reference. And so the contents of this folder, this is my home directory. But the home directory is not where the file structure begins on a computer. There's actually a lot more going on. So if we, whoops, come back, picture. If we look at these photos here, sorry if it's a little difficult to see, but this is my hard drive. And if I click on the hard drive of my computer, I see that there's all of these folders associated with that hard drive. So again, there's something like an application. Bin is something that we're pretty familiar with in bioinformatics. If you ever have to call /user/bin to get a program to run. There's different things that the computer needs, like network or system. And then we have users, and then my home directory is tr. That's what I chose to name it when I got this computer because it's short to type. Other people might have it as their first and last name instead of their first and last initial. So this is what a file system looks like from a high level on your computer. And this here is my home directory. And again, my home directory looks like this. So if we want to see an output that's analogous to this file system structure here, make this a little better. So if I do present working or print working directory, present working directory, which one is it? Present working directory, right? Yeah, I always want to say print, but I don't think it's that. Anyway, not important. It tells me where I am, /user/tr. And if I want to look around, I can use the command ls, which stands for listing. And it shows me all of these same folders that I would see from my home directory, this tr, in my file system. So this shows me a very similar, or the exact same set of folders and files, but it's a different view. I have my system and configured kind of like a Linux system where it would do this automatic, well, it's usually automatic, highlighting of the folders and files. Yours might not be highlighted like this, but that's something that we can set up on computers and post on Discourse how to do that. So ls prints the names of the files and directories in your current working directory. We can also, so we can use this command ls and give it a flag. There's lots of flags that we could use, but the one that we're going to try here is -l. And that's really ugly, so let me zoom out for a second. There we go. And this will give us a lot more information. So by using the command ls and giving it the flag -l, I see a lot more information about these folders and files than I did before. For example, things that we might recognize as sort of intuitive are dates. So these are the dates and times that these files were created. And then this is the size of some of those folders and files. We also see the name of TR, that's my home directory or the directory that these are in. There's other information here that we won't get into today. Yeah, there's other information that we won't get into today. But this gives us, it lists the -L tells ls to list our files in long format. So -L is a flag that changes the behavior of the command ls. Okay. Bigger again. I said that there's different flags that you could give to the command ls. If you want to see what some of those flags are, you could use a different command called man, which stands for manual. And if I press enter, it will pop up a new screen. And this is the manual for the ls command. So we see that the name is ls, list directory contents, and then it gives us a description of what this command does. And if I scroll down, I see that there's a lot of other flags that I could give it. So let's scroll down to the one that we just used. -L says the lowercase letter L, list in long format. If the output is to a terminal, a total sum for all the file sizes is output on a line before the long listing. Okay, so that describes a little bit about the behavior of what we just used, but there's other things as well, like a -M or a -N. So there's all sorts of flags that you can use to control the behavior of -L. Sorry, of ls. Control the behavior of ls. If I want to quit out of man, I can press Q, and it'll take me back to the terminal. Okay, so that takes us to the general syntax of a command. So if we have this command here, we've seen the ls, that's our command. We've seen the -L, that's our flag, and then we have, or an option, and then we have here an argument is /. So most commands are composed like this, where you give the command, you modify it with some option, and then you give it the argument. So in this case, if we run this command, and zoom out a little bit, this runs the listing command, the ls command, on our root directory, which was what was in our hard drive here. And our root directory is called /. And so we see all of these contents that we had seen in this image earlier. Yes?
What's the plus?
This one here?
The plus.
What is this? Oh, the plus sign?
Yeah, plus all the apps.
Let's see.
I mean, the last.
So is there some extra attributes that the directory or file can have on top of the other ledger?
I mean, the DR means directory. The D means the directory. The R is like the W is like actually, yeah. But the last, I mean, the last.
So there are some other things that you can do to annotate, but they are kind of extensions of the basic idea. So each operating system does one max, but we need to go check what it is. But because this is in the /, it's in the root. Like these are very special directories. So it's probably trying to set up something that allows, for example, a user to run something that's in the application directly without having to be super user.
I remember I haven't seen the last
Okay, let's go check.
So this @ symbol, some of these might have something to do with this one that you see here, which is soft linking the file. So the file actually lives at this address on the computer, but it's creating a marker to it at a different location. So that's where these ones come from. And we can see that 3 of them also have them here, but there's others annotated there as well. So we'll look that up and tell you later. Okay. Scroll, scroll, scroll. Okay. So, oh, sorry. If I type clear, it clears my screen and puts my prompt back up at the top, which can be useful, but I'm going to press enter a few times. Okay, so back to our command syntax. Each of these pieces are separated by a space. And then another thing is that capitalization is really important. So for example, in our flag -L, it means something different than -L. So, okay, that is our very quick primer on command syntax and navigating around your file system. There we go. What questions are there about this so far, other than the pluses and the @ symbols? Okay. So now we can practice moving around. So we know how to tell where we are. That's with PWD. And we know how to look around with LS. But if we want to move to a different location, then we can use CD. So let's change directories, CD, into our root directory. So if we do CD/, and then I type LS, I see that the folders and files around me are very different because now I'm in that root directory. And we can check if we moved as well with PWD. Now we see that instead of /users/tr, we only see a slash. And we can move back to where we were with /users/tr. So that's CD/users/tr. And now if I type PWD, I see that I'm back where I was before. Alternatively, we can also use the shortcut CD tilde, and that puts us in our home directory. And one thing that we can see too is sometimes our command line is giving us a little hint of where we're at. So when I change directories into slash, everything before the $ changed into a slash, where here when I'm in my home directory, it changed into a tilde. So because this directory is called slash, the root directory is called slash, it's changed here. Tilde is a shortcut for our home directory. So that's why it's changed there. So that can be a nice hint if you are a little lost and want to know where you're at. Okay. One other thing we can do is CD-, and that'll put you back into the directory you were in before. So if we CD into slash, and then we do CD-, first CDing into slash, we went from our home directory into our root directory. And now with CD-, we are back in our home directory again. So CD- puts you back in whatever directory you were previously. Before we move on to creating directories, what questions do you have?
I just want to point out that we aren't.
That's a great comment. Yes, the TR in this case is specific to my computer. So that's the name of my username on my computer. So your username is going to be whatever you made it, but probably your first and last name or your first and last initial or something like that. If you're on the university computer, it would be like your first letter of your first name, first letter of your middle name, and then your last name. Yeah. Okay, so we now know how to see what directory we're in with pwd, look around our directory at which files and folders are there with ls, and change directories with cd. We can also make directories with the command mkdir or makedir. And in this case, we're going to make one called shell_tutorial. If I do makedir shell tutorial, and then I type ls, I see that now in my home directory, there's this new directory called shell_tutorial that was not there before. And that's the one that we just made. We can change directories into this new folder with our cd shell_, cd shell_tutorial. And if we press enter, we see that our prompt, our command prompt changed. And then I can also type ls to look around. There's nothing to see because we made an empty directory, but I can check that I'm in the right directory with pwd. And I see that I'm in /users/tr/shell_tutorial. Okay, we can use another command called touch to create an empty file. So if I touch myfile.txt, and I can type ls, and I see that I now have myfile.txt. With the commands that we've already learned, how can we tell that this file is empty? We covered it for approximately 5 seconds. How many commands do we know? 5? Okay, which one do you think it is that's going to tell us that the file is empty? Yes, exactly. And now we can tell that it's empty because it says 0 bytes. That means we have an empty file. Okay. We've created this file, but if at a later point we decide that we don't like this file name, we can move it. So we can use the mv command. Let me clear this again. If I say mv, which stands for move, I can move my underscore. And at this point, I'm going to stop typing for a second, and I'm going to press tab. So I've started typing my underscore, and if I press tab, it auto-completes for me. And this is really handy when you're typing anything on the command line because it helps you with avoiding mistakes or typos, and it'll get the capitalization and everything right for you so you don't have to think about it. So if I'm mv myfile.txt, and then I can give it a new name, file.txt. So I move the file from the name that it currently has to a new name. And if I press enter and type ls, I now see instead of having my underscore file.txt, I have file.txt. So we just moved this file from one name to another in the same directory, which accomplished renaming. But what you can also do with this same command is we could move the file from one directory into another directory. So it works for both renaming or moving it to a different directory with the same base name. Okay. Similar to move, we can use this command cp, which stands for copy. So if we cp our file.txt to file2.txt, and now I type ls, I have this file that we moved to this name, and then I generated an exact copy of it named file2.txt. That concludes our very quick introduction to files, directories, and moving around. What questions do you have about these commands? Okay, more of a refresher than it is a comprehensive learning activity. Okay, so now we're going to jump topics a little bit and talk about remote computers. So essentially, the cloud is basically a ton of servers that are all connected together in space, and in one physical location that generates this very large infrastructure. And the way that that's orchestrated depends on the different cloud platform or service that you're using. But essentially, they all have in common is that it's a bunch of computers put together. And there's two sort of main flavors of cloud computers. So the first is you can borrow time and resources from some sort of commercial provider. So these commercial providers are Amazon Web Services or Microsoft Azure, Google Cloud Compute. Those are the main ones. What? There's a lot. Those are the three sort of buzzword big main ones. And then the other option is to use one that's associated with your institution. And those are a lot of times called high performance compute clusters or HPCs. And cloud computers work sort of like this. I'm gonna minimize my terminal so that I can get this bigger. Okay, so let's orient ourselves here. This is the whole cloud computer here. So we have lots of disk storage, lots of CPUs, and then lots of memory. So these are all the components that are essential to doing computation. So you think about your hard drive space, the space that you store the files on a disk. You think about CPUs, which are the sort of the machines that are doing the computation. And then you think about memory, which is where the files are temporarily stored for the CPUs to act on them. This is the total thing, the whole cloud. You carve out a portion of the disk space, the CPUs, and the memory that you need and generate an image of it, which has different like software and that sort of thing. So you configure it with a base setup. And then this is what you're given to work with. So this is your instance. You've carved out this piece of the entire cloud infrastructure to work with. And now as a user, you use a command called SSH to securely log into this computer. This computer has an IP address, and that's a lot like the house address that you have for in your neighborhood or whatever, where it's unique, and it allows you to it allows you to find this computer essentially and send things to it or go to it. What else do I want to say about cloud computing? Anything? Okay. So this is the infrastructure or the use case for if you're borrowing from AWS or Google or Jetstream. It's a little bit different if you're using an HPC, but not by that much. So it's a good mental model to use for most cloud computing that you will be encountering. Okay. So once you have this cloud computer, you SSH into it using your terminal, and then you interact with it with the same sets of commands that we have been using on our own computer. So you orchestrate everything from your own computer, but you're telling the remote computer what to do. Okay. Questions about cloud computing? Okay. Let's reset up our desktop so that I can run things. Okay. So to access this, your remote computer, we use a command called SSH, and that stands for Secure Shell. And essentially what that does is I believe it encrypts your connection to the remote computer, and it also orchestrates a set of permissions that make it so that not everybody with that IP address can access the computer. So it's, again, a lot like your house, where just because somebody knows your address doesn't mean that they can get into your house. You have a lock on your door. So there's two sort of systems that are set up in order to allow people to get into this computer, or let's continue our analogy, into this house. So the first one is there's somebody parked at the door, and somebody knocks, they do SSH into that IP address, somebody knocks on that door, and somebody on the other side says, "What's the password?" And then they say, "Sparkle bomb." And they say, "Okay, you can come in." But it's pretty easy to tell the password sparkle bomb to a lot of people and then have a lot of people start getting into the house that you maybe don't want there. So there's another system that's set up with a lock and, well, a lock and key file essentially. And these are called key files. And they're a lot like the locks and keys that you have for your front door. So there's the doorknob, which has the lock in it, that's forward facing. So anybody in the world can walk by your house and see that lock on your door. It's completely public. Everybody can look at it, but that doesn't mean that they know how to get in because they don't have the key that matches it. You have a key file that matches that public key file that allows you to open the door. And that private key file is just that. It's very private. You don't want to share that with anybody else because once you have the match between the public and the private key file, anybody can get into the computer. So those are called key files, and they allow you to access the instance. And you can create those key files and set up the pair of files on any instance that you own. And it allows you to have secure access to your computer. So there's two ways to log in, with a pair of key files or with a password. What questions do you have about that concept? Karen, you're looking puzzled. Okay. So I am going to demonstrate really quickly what SSH looks like into a computer that I have running on the cloud right now. And I have this set up with a public and private key file. So even if you have this IP address, you will not be able to access this instance. But I want to demonstrate what it looks like to SSH into something. So I type the command SSH, secure shell, and then I type the address of my computer. So in this case, I have a username on this computer, and my username is twriter, and then it's at the IP address, so that unique address for my computer. And if I type this and press enter, I am now in my remote computer. Again, I have it set up so that there's already key files associated with that login. But we see some changes took place when I got onto this computer. So now we have this printout. If you could see it, it would say atmosphere because that is who's hosting this instance. And I see that the last login was at 421, and it's at this IP address. And now instead of TR being my username, it's twriter because that's my username for this computer. And then this is an address for the computer as well. But we see that I SSH'd into my home directory, and I can tell that because there's a tilde there. Okay. Crash course in remote computing. Any questions about this? Okay. I'm going to exit out of my remote computer and go back to working on my local desktop. I did that by typing the command exit we see that I was logged out, that my connection to the IP address was closed. And now instead of having twriter, I have tr, and I'm on my MacBook again. And I'm back in shell tutorial because that's where I left from. All right. So one of the first things that you want to do when you're working on a remote computer is to access files that are on the internet. And we do that with a pair of commands, either wget or curl or curl. Different operating systems come with different ones. I think Linux usually has both wget and curl, or it's really easy to install both of them. On Mac, you usually have curl, but not wget, and there's more overhead to installing wget, but they work pretty similarly. So wget is short for World Wide Web Get, and it downloads the web pages or data from whatever web address you give it. And then curl or curl is a pun, and it's supposed to be read as C, like S-E-E URL. Okay, and if you don't give it any options, it will display the contents of the web page or the file that you're trying to download. So let's see what I have on my computer, and you can do the same if you would like on yours. If I do which curl, I see that there is curl and /user/bin curl. And then if I do which wget, it's in user local bin wget. So using my knowledge that I have of computers, I know that this came with my operating system, and I downloaded this after. So even though I'm on a Mac, I have wget, but most Mac users won't have this unless they have downloaded it themselves. And it's in a different location than curl because I downloaded it. It didn't come with my operating system. So depending on which one you have on your computer, that's usually the one that you'll use to download files. So if we make sure that we're in our shell tutorial, I type ls, I see my files, I can see on my prompt that I'm in shell_tutorial, and then I can double check with pwd, yes, I'm in shell tutorial. Okay, I can use this wget command that I have here, and what this is doing is it's saying, please get this file called from an FTP site of ensemble genomes. And the file that I want is called species-ensemble-bacteria.txt. This isn't going to work. The FTP is probably going to be blocked. Oh well, we'll try it anyway. So this is a file that lives on the internet somewhere. It's on an FTP site that Ensemble has provided for us. And it provides a species list of all of the bacteria that are in Ensemble. So if I want to download this, I give it the address of where that file lives on the FTP site. So I use the command wget and I give it the address. And if I press enter, there's a whole bunch of text about connecting. Oh, it does work, yay. And then eventually it's 100% downloaded. It gives me the transfer speed, which is handy. So it peaked at 2.64 megabytes per second. And it downloaded 7.96 megabytes in 3 seconds. If I want to make sure that my file was downloaded, I can type ls, and I now see that I have species_ensemble-bacteria.txt. Alternatively, we could use curl, and this is the same FTP address. The only difference here is this -O redirects the output to the file name that is in this FTP. We have to do that because, as our pun told us, curl would only show us the contents unless we gave it a flag to save it. So that flag redirects the output of curl to a file and saves it on our system instead of showing us all of the output. Questions about that? Okay. Great, so let's look at our files. The one command that we could use to do that is cat, which stands for concatenate. So if I do cat of, well, let's type ls to see. Okay, it's species_ensemble-bacteria. That's the name of our file. So if I do cat and then species and type tab, it will tab complete for me. Then the whole thing streams across the screen in a way that is utterly incomprehensible. I wanted it to be slower because then I could show you Control C. So let's run it again and I'll be faster. So if I run this, it's going to start streaming across the screen. And if I want it to stop, I'm going to quickly press Control C to stop my command. So I'm going to press Enter, Control C. This time it ended at Fusobacterium necrophorum. Let's not press Control C and see where it ends. Unidentified eubacteria. Okay, so we stopped the cat command midway through by using Control C. And that ends any command that is running in the shell. Okay, that's useful to know. Cat is great if you have a short file or if you want to impress people and make it look like you're running the matrix and have a big long file run across your screen. But it's not that useful if you have a really big file and you want to get to know your content in a digestible manner. So instead we can use a function called head, which will show you the first 10 lines of your file. So if I type head and then start typing species as ensemble bacteria.txt, that was a lot shorter. And if I, let's see, where's my cursor? There we go. If I scroll up, we see that, well, I'm bad at scrolling. Let's make it smaller instead. There we go. We see that, in fact, it was only 10 lines because we can still see my prompt up there. So that shows us the first 10 lines of this file. We could also see the last 10 lines of the file. So I'll type tail and then start typing species and type it without a typo. And that shows us the last 10 lines. Okay, now I'm going to make this bigger again. An alternative to both of these is a command called less. So if I type less and then species ensemble bacteria.txt and press enter, this opens a sort of new window within my terminal in which I can scroll through this file. So now I'm using my arrow keys to scroll through the contents of this file. If I type capital G, I'm now at the end of the file. So this gives me a quick way to interact with my file without having to cat the whole thing across the screen. And you can navigate to different lines if you want to. If I press Q, that will get me out of this view. And then if I want to do this again, run the same command, I can press the up arrow to get the command I just ran. And this time I'm going to give it the flag -S. And if I do that, we see that now it's demarcated these columns a lot more nicely. So -S spreads everything toward the edge of the screen, even past where we're seeing, so that one line stays on each line instead of wrapping around, and it makes it a lot easier to see the file. So this can be really handy when you want to look at big tables that you've created with your bioinformatics skills. Press Q to get out of this view. Okay. Questions about looking at files? Yes. Yeah, so if I start typing, so let's do that command again, less, and then SP, and if I press tab, it finishes it for me. So tab knows all of the files that are in your directory, and it will complete up until anything that it can guess till. So we only have one file that starts with SP in our directory, so it auto-completes the whole thing for us, and that's called tab completion. And if I press Control C, I don't have to run that command that I just typed, and I get a fresh prompt again. Okay, so another thing that people really want to do, yes, there are files that live on the internet and you want to download them to your remote computer, but what if you have painstakingly generated a lovely file on your local computer and it only lives on your local computer and you want to get it to a remote computer? In that case, we use a command that's similar to CP, except it's called SCP, and that stands for secure copy. And what that looks like, oh no, come back SCP. There we go. You SCP, so you give it the command SCP, and then you write the file you want to move and where you want to move it to. So that's the structure of this command. And what that actually looks like with real files. Here, we give it SCP, our username for our remote computer, if we're transferring a file from our remote computer to our desktop. Let's say we've created something called, in our home directory, that's in a folder called outputs, and then the file's called myfile.txt. So we've given it our username, the IP address of our computer, and then where the file is on that computer. And then we say where we want it to go on its destination, which is going to be on my local computer. So I've orchestrated all of this command. I run it on my local computer, and this would transfer the file from the remote computer to my local computer. If you wanted to do the opposite, transfer something from your local computer to a remote computer, how do you think you would do that? Flip-flop, yeah. So this file would come first and that would come second. And just like with SSH, SCP requires either a password or a key file to allow you to get into the remote computer. And different computers sometimes have different requirements for this. So for example, the compute cluster here on campus wants you to use a specific tunnel into the computer in order to transfer data. So that can be system specific. But that is the syntax of how you would use SCP. Questions about SCP or other things we have covered? Okay. So that about concludes our very rapid introduction to using the command line. The lesson that we've been going over today was generated from all of these different lessons that go more in depth on the things that I've covered. And then if you want more practice with specific things, here are some other good lessons that we have used to teach the shell before or think are good. Thank you.